So solution of calcium chloride. We can do a voiceover later, maybe. Okay. A bit of sodium carbonate. So we precipitated calcium carbonate, and now we'll have to centrifuge it. Just need to have the tube balanced.
So what's this stuff, is that?
This is a centrifuge which spins around at 3,000 revolutions per minute, which spins down any solids that are suspended in solution. So press start.
So what kinds of things could you use this for?
We use it for separating precipitates from the supernatant. That's the solution above a precipitate. So you can separate different metals by precipitating them, and the other metal stays in solution. We also use it for analysing food samples in this laboratory. So now we have our precipitate all settling on the bottom of the tube, so we can remove this solution and do further analyses.
Can you turn the thing around with the labels on the
This instrument is a gas chromatography-mass spectrometer. We use it to separate out the components in a mixture and identify. So we fill our little vials with solutions containing our mixture, and then put it in to the instrument, and it gets injected into the machine. The components then travel around this coil, and different components will travel at different speeds. They then come to a detector, and we measure the mass of the molecules in each component. So it's very useful for analysing things like organic chemicals in herbs and spices, for analysing pesticides in environmental contamination. We also use it to check that we've made the right things when we make a new compound. It's used in the food industries and also environmental industries, and it's a very useful instrument. This flask contains acetone, which is the solvent, and then the solute, the stuff dissolved in the acetone, is oxalic acid. We're going to put this on the rotary evaporator. So this is a rotary evaporator. It's used for removing volatile solvents when we're making compounds. So the part here is a water bath. We use this to heat the flask. Inside the flask, the solvent is heated, the liquid becomes a vapour, and the vapour travels up the glass tube, and then it hits the glass coils here. These are filled with very cold water. The vapours will recondense, form a liquid, and end up here in our collecting flask, leaving behind whatever was dissolved in here as a solid, hopefully.
What's all this?
So this is condensation. So the vapour that's travelled up here has hit the cold glass, recondensed into a liquid, and then it forms drips which drip back down into our collecting flask here. So this is our pure acetone solvent over here.
Why doesn't any of it escape through the top of the vacuum?
A small amount will, but because it's a vapour and it's colourless, we can't see it. But most of it will condense and reform a liquid and condense back down here.
So it's not going to be 100%.
No, but it'll be about 95% recovery of the solvent. So we're left with pure oxalic acid at the end. The oxalic acid is now starting to crystallize, which is why the solution's cloudy. You can see white crystals forming on the bottom of the flask.